Alright, so when we look at the scale factor of volume, we know that we're going to take the ratio of the scale factor of the sides and cube it. So that's 4 cubed and 5 cubed. 4 cubed is 64, and then 5 cubed would be 125. When we look at the 7/12, we're going to do the same thing. We're going to have the 7 to 12, that ratio cubed. So we're looking at 7 cubed and 12 cubed. So this ratio would be 343 to 1,728. Now, the next problem asked about the weighted cube. So here we have a 2-inch cube that weighs 4 pounds. And the other one is a 6-inch cube, and they want to know how much would it weigh. Now, the key here is the idea that weight is a measurement of volume. And I think what we need to first figure out, the scale factor of the sides would be 2 to 6. So if I'm talking about volume, the scale factor of volume would be 2 to 6 cubed. So that's a 8 to 6 cubed would be 216. So I can use this ratio then to help me figure this out. I know that I have my volume ratio, 8 to 216 will equal 4 pounds, oops, not 40, 4 pounds to some weight that I don't know. So here I have that 8x will equal 864 pounds. I divide both sides by 8. X would equal 108 pounds. Now, you might want to think, but what's going on here? If I take 216 divided by 8, what I get really is a 1 to 27 ratio. And because it's 3 times the length of each side, so that's a 3 cubed is 27. What that means is that I could take 27 of these little cubes, these 2-inch cubes, and put it inside the 6-inch cube. And so 27 times 4 is 108 pounds. So there's a couple ways I could go about looking at this. Alright, so let's move on to the pyramid problem. So here, again, look at that pyramid of Giza. We've done a lot with this. So in this one, we want to first look at the idea of, if I want to make my model, it's going to be a 1 to 100 foot ratio, and I want to know what would be the side length, what would be the length of each of the sides of the square base. So I can start with my ratio 1 foot to 100 feet and say that I don't know what I want to make each side, but I know that the whole is 756 feet. So here I have 100 feet times x would equal 756 square feet. So when I divide both sides by 100 feet, feet cancels one of these feet, and they're left. So x would equal 7 56/100 feet. So just a little over 7.5 feet long for each side. When I think about how tall, that's also a measure of length. So I would start with the same ratio, that 1 foot to 100 feet. And then I would say that I don't know how tall I want to make it, but I do know that it was 455 feet tall. So when I cross multiply, I get 100 feet is equal to 400 times x is equal to 455 feet squared. Divide both sides by 100 feet. So my feet would cancel here. X would be about a little over 4.5 feet in height. So it's about 7.5 feet wide, and then 4.5 feet tall. And then the question is, well, what's going to be the volume compared to the original? So here I take my scale factor, and I have to remember to cube it. So that is 1 cubic foot for every 100 cubed is 1 million cubic feet. So I'm looking at 1 cubic foot to every, oops, just saw got a little too many zeros here. 1 million cubic feet. And I don't know my cubic feet of my model, but I do know that this is 86,682,960 cubic feet. So when I cross multiply, I'm looking at 1 million cubic feet times x would equal to 86,682,960 cubic feet times cubic feet. So this is actually going to be to the 6. Make it a little bit neater here. So that when I divide by the 1 million cubic feet, they'll cancel on this side. Cubic feet cancels the 6 back to a cubic foot, and then I would have 86, and we'll say 86.7 cubic feet. It's just simplified there, because in essence what happens is everything after the comma for the millions becomes the decimal, and we don't need to write all that. You think about feet, it's about 86 7/10 cubic feet.